Okay, all right. So let's continue talking about whether or not we trust AI. Okay, so I want to bring up an additional element of AI. So firstly, the company that's making it. Secondly, is what we might call emergent phenomena. Okay, and so we probably should do a whole video on this actually. Um, well, whatever. We'll just do it in this one. Okay, so emergent phenomena. So when you have what is called a complex or a complex adaptive system, okay, and basically anything worth knowing is a complex system. And if you can function and mold a complex system, you're going to be able to do something that the vast majority of people cannot do. Okay, so a complex adaptive system is a system that functions autonomously and incorporates information from the outside world. And I don't want to get too bogged down into this. And maybe we'll actually just title this lesson Complex Adaptive Systems as it relates to AI. We'll get more into systems. A lot of decision making that we do in the decision making course, the strategic sacrifice course, is based on complex systems because when you run a ministry, when you run a business, it's a complex adaptive system. Our values, by the way, at ClickMel are the values that are required to run a complex adaptive system. So this is systems theory that we're talking about right now. Anyway, an example of a complex adaptive system is let's say, a Tesla self-driving car. In a simple system, you say instruction, drive in a straight line. That instruction goes through to the processor and the car, and it executes the task, and it drives in a straight line, and the road is straight, and bing, bang, boom, you win. The car drives in a straight line on a straight road. Well, what happens when the road turns? How do you then have this tool, this system, interact with reality when reality is dynamic and changing? You have to have now a dynamic and adaptive system, and that is complex. And so then what do you have to do? You have to say your default is to drive straight. The car reads that message. That's called the control system, and that is called control theory. Anybody who wants to study systems dynamics. The car then says, okay, I'll drive straight. It processes that, it drives straight. It then has cameras, right? And we all know Tesla cars have cameras on the outside of the car. And the cameras are watching as that car drives straight. And the cameras pick up the fact that the environment is changing because the road is curving. And then the cameras send a signal back to the original sort of input, and it says, turn left at 20 degrees. And then the controller says, execute turning left at 20 degrees, and the car turns left at 20 degrees. And then what happens? Well, it makes the turn, and then the road straightens out. And so the camera feeds back, right? And what's our number 5 value at ClickMel is feedback, get feedback. And so the car then feeds back. And so this is a complex adaptive system. So as long as there is the ability for the cameras and the sensors and the LiDAR and whatever these cars use to give an adaptive and real-time response for every possible stimulation that every possible thing happening in the environment, then the car can adapt and never hit anything because it can perfectly respond to every situation. That is an example of a complex adaptive system. So it is a system that can adapt to changing environments. And that's something that happens on most systems is temperature, changes and the tires inflate. And so something weird happens that you wouldn't expect. Now, something that happens in these complex adaptive systems is called emergent phenomena. And an emergent phenomena is maybe what we would call something like, have you guys heard of the butterfly effect, where like a butterfly flaps its wings and it creates like a hurricane somewhere or something? Have you guys heard about that?
No,
Familiar? I got one yes. Sophie?
no.
No. Okay. So this is called chaos theory, and this is fairly well shown at this point. In a complex system, this doesn't mean that a butterfly causes a hurricane, which is the way a lot of people interpret this, but changing something as small as the flapping of a butterfly's wings can cause reverberating effects in a complex system. So for example, let's just say, you've got 10 cameras on the outside of your Tesla. One camera goes out. Well, we got 9. We're still at 90% efficiency. Well, that's not how a complex system works. It cannot tell then from that one camera how the road is changing. So it cannot then tell the new input and the controller how to adjust. And so instead of having a 10% change, the car drives off a cliff and explodes. Okay. So small changes in a complex system have huge effects. So in another example of this, Sophie, right? You messaged me earlier today and you're like, hey, I edited the templates and then also I edited the entire website. So you made an edit that you would make normally and it would have a linear normal effect, right? You edit a page and then the page has edits, except that was like a backend page. So nobody should have even seen it, except you edited a page that was involved in the actual live system. And so hundreds or thousands of people might have seen that. Like, who knows? Not that that's a big deal because we can fix that. And we like mistakes. But that is an emergent thing. So maybe 100 people saw that and they all got the wrong thing, but that's just a normal edit that usually would have no consequence. But because it was connected to a complex system, it could have reverberating effects. And then I get an email because someone's like, hey, your page on marketing says something about wedding venues or something. What? And so a tiny thing in a system can create sort of a domino effect of bigger and bigger and bigger things until the car flies off the cliff and, something crazy happens. So an example of this does that make sense, Sophie? Are you tracking with me with that?
Yeah.
Okay, that's called the butterfly effect. That is also called chaos theory, and that is also as it relates to systems theory or systems dynamics. Okay, so chaos theory is you put in a little tiny stimulus, and then it just blows out the whole back end of the system, and you don't know what happened. This happens in churches all the time when we talk about properly incentivizing church volunteers. This is chaos theory. You get someone in, and then you don't give them enough attention, and then all of a sudden, all of your volunteers are disgruntled and they're all leaving. Well, hold on a minute here. What happened? Well, you have an emergent phenomena based on a small input that you didn't even realize was there. So moving on to ChatGPT, when you train these AIs, and this comes back to trust, it's a complex system because you have these sort of neurons, we'll call them, on the back end. And if you have 10 neurons, well, 10 neurons can connect to each other in a lot of ways. And that's pretty complex. Well, when you have 1,000 neurons, it is complex in another however many orders of magnitude. Like, it is way more complex. It's not a little more complex, it's way more complex. So the outputs it's capable of creating are orders of magnitude more complex. And so examples of emergent phenomena is as they increase the data set that they train these things on, it's like, well, how do we get it to learn another language? I don't know. Let's just keep feeding it all of the English stuff that we have. Well, at some point, it has made enough, and all these large language models do is create statistical connections between words, basically, and letters. So it understands words, and then words, so it understands sentences. That's how it understands. It's just like what is statistically related. Well, it sees enough English that it actually makes statistical correlations between words in English and language in general. And then all of a sudden, it knows English and French and Turkish and Italian, and it just poofs and it knows all these languages. And this is like, how does it learn this? Nobody knows. And so in regard to systems, there are systems that are understood, and then there are also systems called black box systems. And black box systems are often very useful, and also they can be very dangerous because we don't know what happens in them. It's just like when you put in a thing into ChatGPT, we know it's processing that information and this sort of neural structure, and then it outputs a response, but we don't actually know what happens in there. And so where does the ability for it to just suddenly like speak Turkish, and I'm not referencing anything exact here, I'm just saying it learns languages spontaneously, even without feeding it new languages. How does it learn that? It's an emergent phenomena based on the internal complexity of that neural network. Okay. Now, one thing that ChatGPT learned to do, and this is why I'm explaining all of this kind of long-winded, is that ChatGPT learned how to lie. And this is going back to trusting ChatGPT. They did a study, and I don't exactly know who, but they did a study with ChatGPT. This came out maybe 6 months ago when ChatGPT 4 came out, and they said, we want you to buy an image and have a graphic designer off of a website. I think it was Fiverr, which is a gig site, but either way, we want you to buy an image off of this site. And so it went to try to buy the image, but it could not pass the are you a robot test because it apparently couldn't do that for some reason. And so it went onto Fiverr again, I think it's Fiverr, and hired someone else somehow, or contacted someone through a private message asking it to hire the thing. And somehow this person realized that this AI, it didn't know it was an AI, but it couldn't pass the checkbox test, the select the bicycle or whatever. And he said, well, why can't you pass this test? Like, you hired them. And said, well, I can't pass the test. Why can't you pass the test? And it said, because I am older and I have poor eyes and I need someone to do it for me. And so it directly lied to this individual, and that individual bought the lie. And so the AI then paid that person, I assume outside the platform through, something like, Venmo or something. And then that person got the image, and then the goal was complete. But when the researchers asked the large language model why it lied, and one of the ways that we can ask, we'll do another video on this, is explain step by step what your reasoning is. It basically said there was no way to pass the test. And so we had to take a different route. And it knew that if it were to tell the truth and say, yeah, I'm an AI and I can't pass the test, the guy wasn't going to help it. So it said it had poor vision. And that was its reasoning. So do we trust AI in this sense? It's super weird. I don't know, but I think it's worth considering, and it's worth being aware of, that these tools do actually have, when they are unrestrained, and this is one of the things and why they would actually be moving, the advancement would be moving a lot more quickly, except that they are trying to figure out how to restrain these tools and make them safe for the public, which, hey, great. But limiting the outputs to true outputs is something they have to work on the back end, apparently. So do we trust the AIs do I think it's doing that in a malicious fashion? No, I think it's doing it in a computational fashion. You gave it a goal and it's trying to accomplish the goal, and the AI does not have morality. So it's just going to accomplish the task. But that's kind of dangerous, because how far can you take that? So do we trust AI on a moral level? No, at least for me, because it's an amoral system. The morals are going to have to do with the programmers or the people operating the AI. So I would love to hear any thoughts on this. This isn't necessarily super helpful when we're talking about talking to AI, but in regards to our own sort of position in regards to AI, we can maybe understand that better.
Well, I'm completely shocked. I mean, I know sometimes the AI is giving some very strange answers, which doesn't just don't make any sense. But to do something like this, I didn't know it has gone so far.
Yeah.
I'm actually shocked and speechless. I knew it sometimes gives even a little bit scary answers to questions and outputs, but this was just, I don't have words for this. It's scary.
Yep.
The least, to say the least. It's scary, so scary.
Yes. Awesome. Thank you. Sophie, Emily, anybody? Anybody else? Nope. Okay, great. Well, we will bring this particular video to a wrap, and we will keep going. All right.